Friends, this is the fifth lecture on quantum mechanics, and this time I will discuss about the wave particle duality phenomenon. So as you know that in my previous lecture in the year of 1906, scientist Albert Einstein has proposed a theory, and in that theory he told that light not only having wave property but also it has particle property. So basically light is made of small size packets of energy, having particle like small packets of energy, and these packets are called photon and or quanta, and each packets are having energy that can be expressed by the famous equation E is equal to h nu, where E is the energy of that photon, h is a Planck's constant, and nu is the frequency of that electromagnetic radiation or the frequency of that light. So based on this theory, Einstein has successfully described the phenomenon of photoelectric effect that I have already discussed in my previous lecture. You can go through that lecture. So it can be seen that the light has dual character, both wave property as well as it has particle property. So there are some phenomenon of light like diffraction, interference. This phenomenon can be described by using the wave property of light. On the other hand, phenomenon like photoelectric effect can be described by using the particle nature of light. So in the year of 1924, another scientist, Broglie, thought in a similar way. He thought that if light, being an electromagnetic radiation, has particle nature, then the opposite should also be true. What is this? If any particle should also have wave property. So in that way he thought that the matter should also have wave-like property, just like electromagnetic radiation. So he proposed that the wavelength of that wave associated with any particle can be described by this equation: lambda is equal to h by p, where h is Planck's constant and p is the linear momentum, or we can say h by mv. This is the equation for linear momentum. So this wavelength is called, lambda is called de Broglie wavelength. Now you can ask me the question that if particle has wave property, particle also has associated wave, then why not we see that wave coming out from the particle in our day-to-day object, like if we see any ball or any pencil or any laptop, anything, we cannot see any wave coming out from that particle. So why this we can say that this theory is right or no? So the main thing is that if you calculate the wave associated with any large object where the m is very large, if you can calculate this, you will obtain that the lambda value of that particle will be very small, almost insignificant. So this theory, that wave particle duality theory, is absolutely non-significant for daily objects, because these daily objects, their associated wavelength are so small that it do not have any practical significance. So the main significant occur when the size of the particle become very small, in the range of subatomic particles like electron, proton, etc. So if you calculate the lambda for electron, you know the mass of that electron, you know the velocity of that electron. If you put that value, you will see that the lambda, or the wavelength associated with the electron, is almost equal to the wavelength of X-rays. So as you can see, the main thing of quantum mechanics is that the quantum mechanics, all the theory, classical theory and quantum mechanical theory, will give same results for macroscopic object, but for microscopic object, the theory of quantum mechanics can describe all those phenomena very beautifully. Like this, wave particle duality is mainly applicable for microscopic object or subatomic particles like electron, proton, and for macroscopic object, both classical theory and quantum mechanical theory will give same results. Now you can see that the electron have associated wave, and the wavelength of that electron is in the range of X-rays. So this phenomenon is used in the electron diffraction experiment, where we are using a very high energetic beam of electron that is falling on any sample, and this electron wave getting diffracted from the sample, and from the diffraction pattern we can determine the structure of that compound of that element. Similarly, like X-rays. So based on this, this is a very clear-cut experimental evidence that the subatomic particles like electron and proton has their associated wavelength. Now coming back to the Bohr model, you can see, we know that this is the Bohr model atomic structure, where this is the electron is rotating around the nucleus in a fixed circular path or orbit, and the distance between the electron and the nucleus is also fixed. This is the radius of that orbit r, and this is the velocity of that electron, and the radius vector and velocity vector are perpendicular to each other. So this is the Bohr model of atomic structure that I have already discussed in my previous lecture, that is lecture 4. Now what the new in it? The new thing is that de Broglie give us the hypothesis that this electron is having an associated wave also, wave. So this is the wave. This wave is also around this fixed circular orbit. We can see this wave. So now, to satisfy the condition that this wave do not interfere with each other, like so this end of this wave and another end of this wave should meet at the same point, so that this wave should not interfere or interact with each other. So for that condition to be maintained, if the wavelength of the electron associated with it is lambda, then n lambda should be 2 pi r. To what is 2 pi r? 2 pi r is the circumference of that orbit in which the electron is rotating. So that n into lambda should equal to 2 pi r if these waves do not interfere with each other. If this wave interfere with each other, then the wave property will totally be destroyed, which is not possible. So this condition has to be maintained, that the wavelength n into lambda should equal to 2 pi r. Now we know that lambda, the equation of lambda that is proposed by de Broglie is equal to h by mv. So if we put this into this equation, we will obtain nh by mv is equal to 2 pi r. Now if we rearrange this equation like this, nh by 2 pi, taking 2 pi in this region, nh by 2 pi is equal to mvr. Now h by 2 pi is also expressed by h cross. So the equation we get is nh cross is equal to mvr. And in my previous lecture I have shown that the equation for angular momentum is expressed as mvr, L is equal to mvr. So this is nothing but angular momentum. So the final equation that what we obtain is L, the angular momentum of that electron, is equal to nh cross. So this same quantization of angular momentum, this is nothing else but quantization of angular momentum, which is proposed by Niels Bohr. But at that time Niels Bohr give that equation empirically, but we can see that the wave particle duality, theory of wave particle duality automatically derive us this equation. From the wave particle duality we can get that equation automatically. So both Bohr's quantization of angular momentum and theory of wave particle duality complements each other. We can say that both this theory matches each other or complements each other very well. So this now we can say that this theory is not empirical one. We can actually derive this equation directly from the concept of wave particle duality. Okay. So in my next lecture I will talk about another beautiful phenomenon of Heisenberg's uncertainty principle. Up to that we have seen that Bohr's theory of atomic structure has described many things, like from the Bohr's atomic model we can determine the radius of the atom very perfectly. We can also determine the energies of electrons in different level very perfectly, and also we have seen that Bohr's atomic model is also satisfied by wave particle duality, but there is some certain limitation of Bohr's atomic model, that it cannot satisfy the Heisenberg's uncertainty principle. So in the next lecture I will talk what is this Heisenberg's uncertainty principle and why this Bohr model failed to satisfy this Heisenberg uncertainty principle. So till then, goodbye. If you have any doubts or questions regarding this lecture, you can ask me through the comment section, and please do follow and subscribe my channel. In my channel is basically meant for BSc graduate student of chemistry as well as engineering student. So do follow my channel and ask whatever you have a question in your mind through the comment section, and I will go through all the comments personally and try to resolve all your problem in my another separate lecture. So till then, goodbye.